to bring it up.
Yeah, we
Luke, was there any problem with just having that bent pipe with the two little pipe attachers?
No,
the front?
You wouldn't want people with that.
Can I do that?
So hi, I'm Luke Shaheen. I'm president of the SAE team at the University of Regina here. And we're just building a dune buggy on campus to kind of compete against other schools from around the world. SAE International puts on this contest, and they give us the task of designing a prototype that could potentially go into production. So they've designed this fictional company, a fictional manufacturing company, and they say there's a contract out to build a dune buggy. Come up with your best design, and if you get it, you win the contract to go into production. Well, essentially we're given a year. Competition registration was I think October 4th or October 8th, and we're going to competition on June 8th. So less than a year we have to build the car, like do all the design work, everything, raise the money. So we did start a little bit early with the planning stages, but so far we've kind of needed it and we're in good shape.
Do we want to make it removable, or do we want to just
Well, that's the other thing I was just thinking of was we could make the center section attached, and we can make the sides bolt on.
Oh,
and
just
make the guards just have a bolt in them. A bolt that just drops around. Just, yeah, anything to protect the arm. The competition in particular we're going to is in Peoria, Illinois. And it's actually being hosted by Caterpillar, the equipment manufacturer, down at basically their world headquarters. So we're going to be at their testing grounds. The track is going to be designed to break this Baja. So the overall result is they're trying to get as many cars as they can out of the competition in that point. It's usually the last event, so it's where most people break down. But before that, we're also being tested on things like a hill climb, maneuverability, braking, all that kind of stuff. And before we actually even get to race the car at competition, we have to go through a really thorough technical inspection. So just like drag racing or any kind of events like that, they're going to give us a full shakedown. So this car is actually built to very specific rules that we have to follow. So that's something that's kind of been kept in mind all throughout the build process. I mean, you're designing the best Baja you can. So, and then it does offer great opportunities just to have fun with your friends and build a car. Expensive bearing, so it's
No, because it's kinked up. That's really bad.
yeah, I know it's going a bit.
This is what it should look like when we're finished. It has to go in a little bit farther than that, but this is what holds onto the wheel, and then our drive shaft actually goes through that hole. So that's why the bearing has to be so large, which also makes it so hard to press in.
Right. The group kind of started off there. It started off back in the 90s actually, with just a group of fourth-year engineering students wanting to build a cool fourth-year project before they graduated. And it kind of died off a little while ago, and I found out about it with a banner in the Riddell Center, just one of the buildings on campus. Got involved, there wasn't many people, we got it turned around, and yeah, now there's 8 engineering students, 2 business students. I'm actually a business student, so it's kind of weird being involved so heavily into an engineering project like this, but it does really help with the project management, getting all the paperwork done, the documents, sponsorship, all that kind of stuff. Probably the biggest hardship was getting started. Finding out where to start, who to talk to. With it being a program that wasn't really active, we had to build all of our connections again. Like as far as who even to talk to with on campus, who to talk to about materials. Most of our stuff is donated because we are a nonprofit student group. So finding out which companies will really stand behind us and help us learn. Like we got about $10,000 to $12,000 worth of Polaris parts showing up. So it's a lot of stuff to inventory, make sure all the right stuff was sent, make sure it's all gonna work, because we're ordering these things out of a catalog. We don't know exactly how they fit together. Well, really, if I could sum it up in one word, it'd just be invaluable. I mean, there's so much stuff you can learn doing this kind of stuff. Like, you can't even really put it into words how much you learn. Like, you think, okay, it's gonna be a pretty advanced project, we're gonna have to do all this, and then you start doing it and you realize all these little things you learn as you're going along the way. So I didn't think project management would be that much of a struggle, but it kind of is once you get into it, stuff like that, like from a business perspective at least. So
what do you guys
Oh, that's solid on there now. We're attaching this rear pocket. What it does is it protects our seatbelt in case there's an engine fire. We have to basically block any fire from getting through the firewall, and this is just one little cutout. So our seatbelt wraps around here, and it gets retained by these 2 little chunks of metal. So basically just another guard for fire protection. We were a little behind, but we're really catching up now. Things are happening really quick, so it's awesome. Well, we had a bit of a mix-up with the rear axle. Basically, Our rear axle, the A-arms were supposed to be really long, and that allowed us to go over bumps without really suffering much, getting the car bouncing around a lot. And we had to change our design quite a bit. The A-arms behind you, you'll notice they were about 19 inches long in the front, and they were supposed to be that long in the back, and we had to shorten them to about 11. So that really kind of hit us. It took a lot of design work to get that to work out. Mainly it was because the axles over here. We didn't want to splice them because it can be pretty costly. So now that we got a little more, or quite a few more engineering students on the team, we can do a bit more of the CAD stuff. And
this has helped highlight some of the design problems that we've had. This actually, a couple parts of the model happened to come in just at the right time for us to stop building them and redesign them.
Oh, yeah.
Yeah, couple of my design errors that showed up on the full car model, but that I hadn't seen from the just from the basic sketches. Some things are really hard to do just on paper without really seeing it. Just the complex geometry and the angles, and you can take this full model and then, you know, so we figure out what angle we have to have, say from here to on the bearing carrier. And then you can actually create a plane and a sketch that's exactly follows that, and you can just draw a rod on it and figure out the geometry straight from that. Same happening with the trig and trig and trig and trig. So it's been really helpful for this. Yeah.
We're gonna have to notch out these as well.
Yeah, we know.
Okay.
Notch out what?
These tabs, they get here, in on plastic. You remember
Yeah, we know, yeah.
They were supposed to come straight in and loop happen.
Oh, we have to thread more than just those bottom four, too.
Oh, no. The whole thing scoops a little. Hey, Doug, actually, no, I can do it.
Actually, you're gonna have to get this way a bit. That's right.
Good, right there. Okay. Now.
Oh, perfect. That is exactly where it's supposed to go.
We have about 360.
heads up.
You get it lined up.
We decided to do the hardest ones first.
It's been a lot of long nights, but it's slowly coming together. So for the last few days, we've really been trying to get all our stuff painted. All of our brackets were made. We didn't have them painted or anything, so we had to go through, clean them up really well, prime them, spray paint them, get them ready to go. There's been a few issues, just things fitting. Something like the firewall is pretty tight, so getting it in there, it's really hard not to scratch the paint, knock stuff off, and you gotta be really careful with the final fit and assembly, just because how it is now is how people are gonna see it for the next 20 years. So we're also gonna be going up against other schools, so I mean, we don't want to be the guys sitting there with the worst looking car of the bunch. We want to have the best looking car of competition. So this will be a portion of the U of R's image, so it's really important that it's really well done.
We kind of are hoping to break things on our test run, because we want to find out what the weak links are and then fix those before we go to competition.
For sure.
So I think we do expect to break things, actually.
Yeah.
We'll see.
We took it out, pushed it around in front on the pavement in front of our garage here, and since we have a solid rear axle, which means both tires spin at the exact same rate, so what happens with that is when we try and turn, those wheels skid and they slide, and it really doesn't like to turn. So we're really hoping we can overcome that in the dirt and break loose with traction and hopefully make corners pretty tight. Verdict so far is it's awesome. It seems to be working great. Everything's going good. Bit of a new issue with toe in now that we're just trying to think through, but it should go fairly well. So yeah, we have a week left before we head out, so. Our main goal was just to make it to competition and do our best, so I'd say we did that and a little bit more. So they tested us on things like a hill climb, they had a rock crawl, they had braking and acceleration, and then the endurance event was kind of the grand finale where they basically put all cars on the track. There's 115 cars going around the track, or 100 by the time they disqualified a few, and yeah, we went on for 4 hours trying to go around this course. The rock crawl was pretty gnarly. It was going up a fairly steep hill, and they used the heavy equipment at the Caterpillar facility to move some massive boulders in place, and there was gaps that our car could easily fit in. It's actually what ended up catching us and making us stop where we did, but yeah, it was basically just a bunch of huge rocks that we had to try and climb through.
Well, both the maneuverability and the rock crawl were pretty amazing because we didn't really know what to expect and didn't think our car was going to do as well as some of these teams that have really highly engineered vehicles. And we did awesome, especially in the rock crawl. And the maneuverability, we had some problems at the very end with a shifter linkage cable that kind of broke on us, but it would have been a really good run had we finished that one.
Yeah, the biggest challenge was just being a first-year team. We had no idea what to expect. We didn't really have a chance to really test the car thoroughly because it really did come down to the wire for us. The rock crawl, like I was saying, was really gnarly. It was actually one that most teams couldn't believe how bad they made it. Like it was extreme. But we originally weren't going to do it, and we were worried about wrecking our car, so I said, well, let's take it easy. We did a nice soft pass and we ended up getting 27th out of 115 teams. So if we would have made it another foot, we would have been close to the top 10. So for a first-year team, that's kind of unbelievable.
None of us have ever done this before, and we don't have anybody who has done it who could offer some advice during the build. And that kind of ended up being one of the things that bit us in the butt in the end because it was some little tabs that bent on us during the endurance, which caused us to have to leave the race.
All in all, it did really good. The rear axle was what kind of caught us in the end. We bent some mounts, but other than that, it was taking massive jumps, 3-4 foot drop-offs like nothing. And I think I hit about 5 or 6 feet of air when I was driving the endurance, so came out pretty good.
Well, it was a really good experience just in general, but it was a lot of fun meeting all these teams that have done this for 20 years, and they have a lot of really interesting things to share with us. And they're a lot of fun guys too, of course. They're just like us. They like working on cars and having fun.
The networking of it was huge. Like, there was teams everywhere. Everyone was willing to help each other out. We had a few issues with safety wiring and stuff where we had to drill a hole inside of a bolt, and we didn't have the tools, but a lot of other teams stepped up to the plate and were like, hey, come use our stuff. It's right here, it's set up, we'll show you how to do it. So it's awesome. And we did get to meet a few nice guys too from different universities. One of them was Laval, another ITS, local Canadian schools who are some of our top competitors. So they actually both placed, I think, first and second in the competition. So good guys to know and borrow a bit of information from. Overall, the best feeling I got out of this was the overall accomplishment of just trying something that no one else has done in 10 years. People didn't think it was possible for us to do it again, but we stepped up to the plate and just making it happen. That was the greatest feeling of accomplishment I've got in a long time. So.